Test. Perfect. Just spoiling all the fun. Let me go to the intro slide. Yes. So, hello everyone. My name is Filip. I'm currently, as nicely introduced, pursuing my PhD at the Technical University of Munich in the area of distributed computing. And in parallel, I'm also a co-founder of Space Computer. And today I'll be presenting aspects on how can we actually send trusted execution environments, or in short, TEEs, to space, and identify what additional aspects it can provide to the users on Earth, and how we envision the future frontier with respect to confidential computing in space. So I have several points to cover today. In general, of course, because we are rather a young project, we also have to take the responsibility of educating our audience with respect to why do we foresee that the space is the next frontier, and why today is the good timing to actually try to send and build a distributed system in space. Then we'll dive into the aspects on what is actually the tamper-proof infrastructure we aim to achieve, provide an overview of our two-tier architecture that many of you might be already familiar with from the Ethereum ecosystem, and try to apply it to the context of layer 1 solutions running in space. Of course, highlight briefly the smart contract capabilities, dive into some of the challenges that are unique for our L1 but also L2, and provide aspects on actually how Space Computer can help with our current solutions we have on Earth to make them more secure and robust. So firstly, why do we actually currently see the push of and a good timing to actually build a new solution in space? So the data speak for themselves. In the last couple of years, we have seen launched more objects to space than in the past decades, and we also see, more importantly, that the cost of launching any amount of satellites, or especially the payload sizes, is becoming cheaper over time. Meaning that in the maybe 10 years ago, before SpaceX was a thing, you would have to pay hundreds of thousands of euros for each kilogram of payload you are launching. Nowadays, the cost is becoming part of it, meaning we are talking about thousands of euros, and of course with the competition that we currently foresee, either from SpaceX, Blue Origin, you name it, the payload cost should be only decreasing. What does it mean to us? It means that now is the good timing, and we can see it on a regular basis when you look into the news, that more satellites are being launched to provide confidential computing or in general type of computing in space. Maybe some of you registered 2 weeks ago. China has launched a new complete constellation of satellites for AI running in space. We have projects like Loft and many others that are building full data centers in space, where the main promise of the technology in space is to directly collect all of the energy from the sun without the need of relying on a power supply from Earth itself. So definitely this is something where we envision the long-term future. And of course, due to the aspect that you are in space, you also can actually improve on the latency, not as of now as it is, but of course moving forward, due to the fact that you are in a much better environment where the data can propagate with much less delay itself. And more importantly, as many of you maybe are already users of such technologies or have devices equipped with it, we start to see that from traditional solutions such as Iridium, there start to be broadly available solutions such as Starlink that of course will enable, maybe not as of now, but in the future, much more performant communication among not only to users to satellites, but also intra-satellite communication while they are running in space. So, what is Space Computer? Our target we have as of now is to build a new layer 1 solution in space, meaning that actually we really want to run L1 among the satellites, running consensus among satellites, and in addition to that, we are aiming to each satellite itself providing confidential computing capabilities, meaning that each of the satellites we called spaceTEE, or Space Trusted Execution Environment. I will dive into it in upcoming slides in more detail, what is the unique aspect of the TEE. We of course, as many other L1s currently are providing, we envision the future where actually you need to have programmability capabilities in space, and therefore of course we want to be part of it with smart contract platform capabilities. And of course, as of now, we envision several use cases. You can think of it like a coprocessors for TEEs, but of course we see the foreseeable future that there'll be more and more computation and orchestration of the computation happening in space, for which we want to provide a robust marketplace and payment layer among other satellite providers as well. Of course, we currently have just published a blue paper last year in November, and we are currently working on white paper with more specific use cases and application that I'll be happy to discuss with you during the runtime of the conference as well. Looking at the architecture briefly, the idea is, I have to be pointing somewhere over there, I believe. Maybe it's gonna work or not. Doesn't seem to be the case. So you have, of course, the Earth components, and around that we will have the individual satellites that will be forming together the distributed system, which we call, of course, space computer. And then you will have additional satellite service providers that will be orchestrating their payment systems and others across our platform itself. So, what does Space Computer provide to users on Earth, and why should you possibly consider using our solution? So in general, we envision that we will have individual satellites providing capabilities to its users, but of course, depending on the applications, you can also have the full-fledged aspects of actually distributed system capabilities. So you can think of it that you can just communicate with a single satellite. It will be providing trusted execution environment capabilities, like for example, you are used to it interacting with Intel TDX or others, just with a slightly different and hopefully improved threat model. You can, for example, by interacting with a single satellite, collect CTRNG, or as we call it, Cosmic True Random Number Generator. Or you can have a custody wallet solution also stored on the individual satellites. So this is just the aspect of a single node solution, but of course overall what we envision is that you will just have the seamless experience as you are used to from interacting with your blockchain of your favorite L1 through RPC nodes, have dedicated communication links that you will be able to communicate with your peers and have in general additional aspects. We don't only envision ourselves that we'll be communicating with users, which is of course important for us, but also want to provide robust solutions to other L1s, for example, with respect to secure bulletin board aspects or checkpointing, where you can think of it that since the infrastructure is running in space, it's very hard to be tampered with, and therefore you can think of it like an additional settlement or a robust layer where actually peers can also store that information from Earth itself. Looking into the aspect on why are we motivating to build a space computer as it is as of now, following example of Ethereum in this case, to have a two-tier architecture. As you might have guessed, we are kind of constrained when it comes to building something in space, either on both communication but also on the computation, of course. So for that, in order to scale, we have to look into the ways on how can we achieve it. And for that, fortunately, there is a huge body of research already done that we can look into and actually apply it to ourselves as well, with of course the additional constraints, communications and other parts that will enable scalability and usability to users, while actually also providing different type of guarantees. For example, robust communication among the peers, since when you think of it, the space satellites, they are available pretty much from anywhere because you have them always orbiting over you and you don't have to rely on the underlying physical infrastructure on Earth itself. As long as you, for example, have Iridium or Starlink terminal, we envision that you will be able to communicate directly with our infrastructure. Of course, since we see that the computation and communication capabilities of space satellites will be improving, we also have to consider aspects of dynamic upgrades of the consensus mechanism itself, which is something that we are now currently actively working on how to make it into reality with the work on the white paper itself. So overall, where we see our aspects is that we will have a very robust L1 that will be running in space, and we will have L2 solutions for scalability itself. So this is something where we also try to provide some novel approach that, of course, as we know, for example, from Optimistic or Zero Labs, we want to a little bit push it forward in a combination with state channels to also provide additional usability guarantees itself. We are highlighting this part in the blue paper. I don't have time to dive into it nowadays in more detail, but just let's continue further with where do we actually provide resilience on two levels. I was talking about communication and computation, so let's dive into the aspects of communication a bit more in detail. As of now, we are relying on the Iridium network. Some of you might already know it with respect to MP watches, you name it, when you are in the middle of nowhere, you are still able to communicate. So this is the current state-of-the-art basically solution that is providing to the satellites as well capabilities to provide intra-satellite communication. And for that, Iridium itself is orbiting already around us with roughly 70 satellites, enabling us to provide good coverage over the Earth. We are currently partnering because we see ourselves as a protocol company, software company, with various types of hardware providers that are actually providing us the access to the compute itself. But of course, we envision in the future that we can expand on that. And we basically are trying to combine both of these capabilities together to build a robust protocol that is having unique hardware capabilities. And of course, it's providing, most importantly, resistance to type of denial of service attacks, because the infrastructure itself is providing this type of capabilities. So this is something that is very, I think, unique set of feature. You can think of it like also as a fallback mechanism as well to current systems on Earth, where maybe you are just like used to rely on your internet service provider. But of course, in case you want, you can also have a dedicated link that is slower, maybe more expensive, but serves as a good backup solution for your type of communication via the Iridium network itself. The second flow is the focus of, I would say, the 2 days talk mainly, which is the computational resilience, that we focus on the aspect of spaceTEE. So this concept is already introduced in 2017 by the previous co-founders of, at that point, CryptoSat, Aptos Orbital called nowadays, that introduced the general idea of physical isolation. Due to the fact that you are running your satellite in space, it's very hard to go and tamper with it, because it's rather difficult to get a hold of it because of the location, right? And also actually the speed as well. So even though currently there start to be more and more aspect of adversarial activities in space, still it's rather challenging. But of course, we don't want to stop there. We want to expand on it further, which I'll be talking on the upcoming slides. But for those who are not familiar with the concept of TEE, you can think of it like a dedicated, isolated region on a CPU that is providing additional instructions to the users when it comes to building the solution. And it aims to provide a secure location for your both code and data itself. And in general, it aims to offer confidentiality and integrity. And also, depending on the solution you are using, it aims to support attestation capabilities. Meaning that this is, I think, very crucial feature that we are aiming to have as well, of course. And the aspect of remote attestation is that I can convince you or anyone who wants to interact with the infrastructure that actually your code, your data are properly being executed inside of this secure environment. And you can do this through various approaches. And there also, we will talk about it a bit on the upcoming slides, with a different root of trust. But the general idea is that you are confident that your transaction, your confidential transaction, or you can think of it as a general compute, has been executed inside of the TEE. The additional capabilities that it also is providing to provide transparency to its users, because you actually, with the attestation itself, you also know, for example, what type of binary or other informations are running inside of the TEE as well. Meaning you can, for example, attestate the guest operating system, possibly also the host operating system, depending on the model, the binaries and other parts that, of course, if you have later on open source the individual components, others can take, recompile it, and verify that the information that actually they are interacting with doesn't have, for example, any backdoor. And with that, you are building the root of trust and the aspect of interaction with such solutions. Maybe over the past years, you have heard, especially I think last year, it was becoming really a hot technology, just providing a high-level overview of what are the various types of TEEs out there. So in general, there are two main categories: process-based TEEs and VM-based TEEs. For the process-based solutions, the general idea is that you, as a host operating system, are running doing your regular operation, you are running your binary, and then just like a single part of the process are basically executed inside of the TEE. Some of you might already have heard of Intel SGX, or many of you actually might have it on your phone, is the ARM Trust Zone. And then we have the other solutions, which I would say are mainly enabling currently the usability coming with security, which are the virtual machine-based solutions, such as Intel TDX, AMD CVSMP, and especially I think interesting for us is the ARM CCA technology that is basically building on top of the trust zone aspects, but allows for additional privacy and additional isolation. And here we stand is the aspect of spaceTEE, which is providing the physical isolation, but of course we want to provide the software isolation as well. So you can think of it that we are layering different type of TEE technologies together, where we try to have similar or possibly smaller trusted compute base as the VM-based solution, but want to, of course, build on already established solutions that are out there that we can actually later on launch inside of on the satellite itself. So briefly speaking, we can think of it, we, for example, take ARM Trust Zone, expand on the threat model of Arm Trust Zone due to the physical isolation and other aspects of the verifiability of the individual software stack on the individual satellite to achieve much better security guarantees that you would have received by running the same technology on Earth as well. I didn't mention it here on the slide, but of course, for those that are in the TE space, I think a very hot technology we have seen also recently, for example, in the Ethereum ecosystem, is the focus on RISC-V. And this is actually something that we are very actively looking into as well, because, for example, there is a Keystone project that is enabling a full-fledged open source capabilities that actually can be used and deployed as well. The very interesting part of RISC and ARM, why they are the main focus points for us, is due to the fact that we are computation constraints. That is one part. So we are usually running ARM-based architecture, in the future possibly RISC-V-based architectures, but also we are power constrained, meaning that you cannot just take any off-the-shelf server that will be running Intel TDX and run it in space. We are also constrained on the power budget itself because of the cooling of the equipment we have as well. And of course, the more power we would need, the more solar arrays we would need, which of course make the whole payload much heavier. So we have to balance among all of these capabilities to achieve what we are aiming to achieve with the robust infrastructure itself. And now kind of coming into the part of that we outline what are some of the features we can offer with respect to computational and communication resilience. Let's look into how can we possibly collaborate with various L2 solutions that the first one we cannot really help with, but when you look at the ecosystem and some of the discussions, there are known bugs in the implementations of either the smart contracts or actually the proving systems as well, that currently are very hard to be exploited due to the fact that it's a rather centralized solution, right? We are aware of that as a community, but it's something that it's still worth pursuing to improve, and I think this is actually what is actively happening, and for that events like this are very important, where the soundness of the implementation of has to be improved and validated. We also start to see more shift towards instead of single prover models to multi-prover models, meaning that you are, for example, combining TE together with zero-knowledge rollups as they are, that are actually providing additional incentives to the operators and their users. We currently also know that there is a certain level of trust that is added into the sequencers with respect to censoring, of course, information, providing availability to the users. And of course, in case, especially there was a really nice paper recently on Arbitrum, in case, for example, you have the period when you can actually, as a L2 user, try to disclaim that the transaction is possibly settled on L1, is actually relying on being able to communicate and not be censored before you reach the L1. So for that, there start to be some interesting challenges with respect to that actually are possible to be solved using some form of external communication to the users. Another part we definitely see that I think is being actively discussed with various frameworks is interoperability, where we see that there are various approaches with respect to the challenges we foresee. So we see ourselves to look into the ways on actually how can we improve on the current state-of-the-art solution using our unique capabilities as they are. So in general, what we want to provide is a defense in depth mechanism to existing L2s. So this is something that we definitely foresee that the future and the communication capabilities for L2s will go in the multi-proof direction. I think there was already a thesis about it recently from Vitalik with respect to looking into always 2 out of 3 solutions. And this is definitely something where we foresee that with our spaceTEE guarantees, we can actually provide a very comparable security guarantees or even better than what we see on Earth. So this is definitely something where we foresee that we could play a role. And of course, in general, this also helps with the aspect of the decentralization to the current systems as they are. And I think what is maybe more interesting to the users itself is to provide additional pre-confirmation. So instead of waiting for way too long time before the transactions get actually finalized on the L2, or when the sequencer itself is not able to communicate with the L1, we can try to provide additional guarantees, which we call pre-confirmations, where we envision to have a dedicated communication channel between the L2s and L1s, where we can basically quickly validate the state update is valid, and later on try to provide this form of attestation to the users on Earth, which actually, as it is, aims to provide a good way that can be deployed across different L2s as well to provide additional security to the users itself. Here is the roughly outline how it would look like. So as a user, you are interacting as you are used to with your favorite L2, and then the L2 itself would be communicating with us, with our validator running in space. That will provide just a quick state update of the root of the market tree, and just like provide an attestation from within the spaceTEE in space, provide this information to the L2 on Earth to actually achieve this form of pre-finality to the users before it gets settled on the L1 itself. So overall, with this approach, we aim to balance the aspect of security and usability to users, while I think in general helping the ecosystem with wider adoption as it is. So for that, we are currently actually looking into the capabilities and the implementations of several L2s that are currently in our pipeline, and we hope to roll it out soon, either to our own L2s, but also future L2s as well. So summary, what we can offer to L2s, we covered, I would say, most interesting part that might be providing interesting capabilities with respect to the mixture of computation and communication resilience. We definitely want to provide step-by-step rollout to selected L2s. The reason why step-by-step is, of course, that we are rather a small and a young team, and we cannot integrate with most of the L2s, but definitely what we are trying to achieve is to also have standardized solution that can later on enable other form of interaction with others. And of course, as we are rather growing, we have announced recently our pre-seed and are in the last process of finalizing our seed. We envision that this will be something interesting for us as we are building the infrastructure as well, from currently having a single satellite to having in the future a full constellation of satellites as they are. We are currently in the last stretch of finalizing the white paper with respect to actually what the consensus, how it should look like, how it should scale moving forward, finalizing the specs of the L1, and also, as mentioned, looking into the aspects of the integration. And of course, we are always open to discussions with respect to talking with various L1s, L2 foundations, looking into various wallet providers that might be actually interested in maybe considering a pilot with respect to custody wallet deployments or other type of solutions. In general, we envision that we are building a permissionless system where other peers can also later on run their proof of satellite in the future and deploying their own solutions in the space. And actually what are we currently providing is the last item, which is, we can think of it that we are already having a public preview of our capabilities using the Toronto number generator on Earth, where we are currently looking into applications regarding NFTs, of course, but also are looking into solutions related to AI and other actually integration of randomness into various consensus protocols, but also other cryptographic protocols that heavily need randomness as well. So I'll be here all the time, so happy to find out more. Get in touch as well. We are actively working on it, and we are currently building the community that is, of course, and should be space built, and happy to discuss more. Thank you very much for your attention.
Thanks a lot, Filip, for a wonderful presentation. So any one of you got any question? Oh, perfect.
Yeah, I have actually three. So the first one will be like, if I'm not mistaken, all the Tees require some kind of key ceremony, right?
Correct.
Yes. So what's your procedure for that?
So can you elaborate? What do you mean by tea ceremony?
Like, well, they need like to be in order to be trusted. They are not like you know, like trusted from the start. It's like some kind of initial, like, you know, like. I'm not sure key ceremony is the correct term for this.
I see what you mean. Yeah. You mean like when it, for example, comes to let me go back to the overview of the various TEs. Exactly. So, for example, when it comes to Intel TDX or AMD, you are basically at the beginning communicating with Intel or others to basically get verified that this is a valid CPU that was issued by Intel, and later on the attestation has the certificate chain from Intel that you later on you can basically trust the machine.
And the secret is done by Intel, so you do not touch like
correct.
You have secret in the chip, you cannot access it, and it's like Intel
exactly.
verifies that it's like this.
Exactly. That's the part I think where ARM-CCA and especially I think the RISC-V is very attractive because you don't have to trust Intel to be generating the keys on the chip, but you can actually just get them generated on the fly basically, which I think is a very unique property that we are aiming for. So that way, even if Intel claims they don't see, still there is a bit of a trust issue, right, if they actually don't see it. Yeah. So this is something that actually the other technologies aim to provide, and this is the reason why we are also actively looking into them, because it's not only providing the better physical isolation, where if you, for example, look at Intel or AMD, they don't consider sophisticated hardware attacks as a part of their threat model, but of course you still have to consider the aspect of the key generation process that we aim to resolve in a better way.
Another question. Sorry.
Yeah, thank you. That's a very nice, cool idea. My question is, so, you know, in a blockchain, you are supposed to run a decentralized system in which different entities run the nodes. So my question is here, who is running the nodes that are in the space? And also, isn't there a concern of, you know, when you give the node to be launched into space, that has to pass through a company that has a rocket, and during that time, they can tamper with the hardware, right? And all of the nodes that are going to be in space have to go through that, you know, company. So is there any, you know, risk there or trust assumption that you have to be there?
Yeah, so first, the comment on who can run the node. So as we kind of foresee ourselves moving forward, we want to create a blueprint, basically, of a suitable design, where later on we can share with the community and motivate people to run it. Because of course we envision to have regular incentives for running and participating in the network, and the blueprint should be there for the sake of course decreasing the cost, so others can just easily go to a manufacturer of choice and get their satellite built and launch. As mentioned, this is gonna be, as of now it's more expensive, but we envision the future where it's gonna get cheaper. And of course there will be some upfront costs, but overall we envision that our tokenomics will allow to cover the cost of you launching. Same as we, for example, when it comes to getting a certain amount of stake, here basically you have to get a certain amount of hardware to basically be able to participate in the network. So this is on the first part. We are still finalizing the details, but are happy to brainstorm on that part because it's something that we hope to build together as a community. And on the second part, of course, there are possibilities that the malicious space provider, let's say, who wants to launch provider, can tamper with it. This is something that we have to consider, but there are also solutions on how to overcome it. So for example, due to the aspects of launching and later on deploying the satellite in space, you can, for example, create your model of the satellite on how it's supposed to, for example, behave when it's properly sealed and not tampered with. And of course, if the launch provider, for example, was tampering with during the launch, certain aspects of the physical properties of the satellite would be different. For example, the inertia and others could actually later on serve to detect such type of behavior. So this is something that we are looking into. There are already solutions. This is always a matter of cost and the gains you are getting from that.
I have a question regarding your L1. Are you planning to have any computational capabilities on L1 in order to open to like space economy to actually allow to run any computation on the L1, or is purely for the consensus?
So you're complete. So I think I mentioned in the beginning. So of course we aim to be a smart contract platform, meaning that actually we will have EVM capabilities, or basically currently we are aiming together to have EVM capabilities. So you can just deploy the smart contracts you're used to on our platform, where we of course want to integrate it together with the TEE itself. So basically you will have a confidential virtual machine where you can deploy your stuff.
But run on L1 or L2?
On the L1, on the
L1
in space, exactly. Yeah, so you will have, of course, the security guarantees for the consensus client itself, but also for the virtual machine itself. Yeah. Mm-hmm.
Okay, perfect. Thanks a lot for your answers. And we are moving to the next topic. Thank you.
Thank you very much.